Okay, so welcome. Today's topic is about PERT estimation technique. Usually PERT is more than only estimation. It's an analysis. I'll say some more words to that, but the idea is mainly that you get an idea about how to estimate a bit better in your projects. And for example, why should you improve on estimation? PERT, the name PERT means Program Evaluation and Review. This is a network analysis technique, and you usually use this to estimate the project duration. For example, when there is a certain degree of uncertainty regarding your individual activities or regarding your estimations. So the reason why you should use a specific technique for estimation is, imagine you estimate some activities or a task. Usually you say, okay, I'm pretty confident that I will be finished in 5 days, for example. And then the question is, of course, are you really finished after 5 days? And also the other question is, how confident are you that you finish your task after 5 days? Maybe you're already in 4.5 days, or you need 6 days, and so forth. So this 5-day estimation from you or your project group is just a number. And the question is actually, what kind of number is it? Is it now optimistic estimated, or is it do you have some buffer time planned in there? And that's actually all the things you kind of can and should consider, or you should be aware of that. So if you provide only one number for an estimation, that's kind of pretty vague. Yeah. With PERT analysis or with PERT estimation, you use probabilistic time estimates. So it's duration estimate based. And what you now do, as I told you right now, you don't provide only one number. So you do not base your estimation on only one number, but you think about an optimistic, a most likely, and a pessimistic estimate. And you do this usually for every task. Yeah. So you can use this three-point estimate, so to say. And why should you do that? Well, you think a bit better of your task, of your activity. And by having a look at these 3 values, you may get a better idea. You think better on your estimation. So that's actually the first step. Yeah. So why do you need it? So where is the problem? I mean, maybe you're kind of, or you think you're kind of good in estimating. And for example, if you write down now in a network diagram, it could look something like this. Yeah, so you have all your activities or your task drawn in a network diagram, and on the left side you see project is starting. You create the use cases, a use case diagram. You create mock-ups. You create the design. You go on implementing and testing, and then you have the project end. So here in the network diagram, you can see which task is first, which task is following. And you see also how much time does it take. Yeah, so you see when it starts, when it ends, and you see the number of the days for each task. And if you remember the critical path, when one of our lessons before, you can have a look. Okay, what is now the critical path, right? So it's the longest path and you see, okay, this is a critical path, create use cases, create mockups, create design, implement admin, test admin, and then you have the project end, right? So I have known some numbers in here, and if you only think about one number, you only provide one number, you have a critical path, and imagine you provided right now a pretty optimistic values in here, right? So you're just doing an estimation, and by rule of thumb, and you have provided optimistic values. Then what happens then usually is that if something changes, for example, if creating the design takes 1 day longer, it immediately, due to the critical path, has an effect on the project end, right? This is, you can easily analyze that by having a look at the critical path. So far so good. Huh? So, but the question is, so you have no buffer planned in here, obviously. So you did not consider any other estimation technique. And here it can and it will help if you use a PERT estimation. Yeah. So you have a look at these 3-point estimations. And there's a formula which you can use. This formula is generally based on the modified beta distribution. So it's simplified in project management. In the books, you find always this simplified formula for PERT and for the standard deviation. You'll see it in a minute. And the formula looks like this. So your time estimate, you do the following. You say the optimistic value plus 4 times the most likely value plus the pessimistic value, and you divide it by 6. So that's a pretty simplified formula. This is not the super precise formula, but it will usually do the job, and it's also described in the books. And by calculating these value and not just taking an average, you get a bit more better value than just taking one number, by taking now 3 numbers and calculating the value out of that. Yeah. So let me show you an example. Just a question. So think about how many workdays do you need for developing a login page? Yeah. So you consider the optimistic estimation. Yeah. So let's have a look. Somebody an idea? How long would it take for you for an optimistic approach? So optimistic would be like everything is fine, everything went well. So nearly perfect. So, and this is actually the optimistic estimation. How long could it take? Think of, I don't know, project, in project 3, you don't have login right now, but think of project 3. In SOFA, you may have login somewhere. How much time could it take optimistically? Any ideas? Let me go through the example. Let's say it takes 2 days. Everything is fine, no problems, perfect performance. And I say, okay, optimistically, nothing goes wrong, no bugs, nothing, 2 days. Yeah. And then you have a look at, for example, another value, and you say, okay, I have a pessimistic estimation. Yeah? So you really say something is going wrong, some bugs occurs, some issues to solve, some things really go wrong. Problems with the framework, backend not available or something. So not like there's an earthquake and I must stop working. This is not what you're gonna look at. But just think of if everything goes wrong in developing and I have to redo some parts or something, what would be a really pessimistic estimation? Let's assume you say, and it's still an estimation, right? Yeah, it's still an unprecise estimation, even though you provide 3 values. Yeah? You say 10 days. Yeah, and then you have a look. Third estimation, you say most likely. So the most likely estimation is, yeah, you are quite confident that this is your number, or think of it as you would provide this number as a normal estimation. So if you don't think about PERT estimation, somebody asks you for an estimation and you really want a number, you probably would say by just thinking of this number, so the most likely number. Let's say you say, okay, it takes 4 days. Yeah, so now you have, instead of only saying 4, for example, maybe you would say 4 if somebody asks you of an estimation. Now you have 3 values. Okay, so far so good. You don't estimate now the average. Yeah, so, and if you have a look back at the formula, then you would calculate 4 times. So it's a higher weight on the most likely value. And you say roughly 50% is going the one direction and 50% the other direction, so to say. Yeah. So we put the numbers in there. You say 2 plus 4 times 4 plus 10 divided through 6, and you have not 4 days, but you have 4.67 days. Yeah, so it's kind of a bit higher. Okay, so far so good. The value is a bit different right now. Normally you would have said normally 4 days, for example, so it's a bit higher. You could say, okay, I can also plan in some buffer, right? So this is what I can also do. For example, 10-20% buffer per day. Wouldn't this do also the job? You could argue, yeah, that will also be fine. But you can and you should do even a bit more. So if somebody asks you for how long will this task take, the question is, will this estimation exactly match? Yeah, so you have now a better number, whatever better means, because you just thought a bit better on you choose a number by calculating something. It's kind of a bit more precise, so to say, even though it's still an estimation. Yeah, so you could have argued you just put some buffer time and that's it. So why doing this? But you will never exactly match, of course, this 4.67 days still. Even you would never match 4 days. And so maybe it's in real, it's then 3 days, or it is 5 days or something. What else? So generally, providing one value for an estimation is normally not saying anything at all. So because you have no idea about the confidence. So how confident are you that you really reach this value? So are you very, very sure? No, you have maybe a better number, kind of, but still there's a chance that something goes really wrong. Yeah, so still there is a chance, remember the pessimistic value, that you are going into the direction of 10. But again, so that everything really goes wrong and that you really need 10, there's not such a high chance that you have 10 days instead of 4.6 days. So the confidence or the chance of going into the direction of 10 is actually quite low. So you're always wrong. If you even say 4 days or 4.67 days, in the end, if the job was done, if the task was done, you can be sure it will never be exactly 4.67 days. On paper, maybe yes. So if it takes 5 days, on paper you have reached 4.67 days. But if you are really calculating that, you will never exactly match this number. So just a number. So better estimation, real estimation will never be exactly this number. And to provide a more professional estimation, what you can now do is you can take the standard deviation into consideration. Yeah, so you know the standard deviation maybe from math. Again, this is a simplified formula here, because for us it is fine, because these are all still estimations. There's kind of an uncertainty in there. These estimations are imprecise. These are no measured values, kind of. So it doesn't also make sense to have a super complex mathematical calculation. So this is usually in every project management book, it's simplified. And how you do it is you say sigma, you calculate it by pessimistic minus the optimistic value, and you divide it through 6. And then you get the standard deviation, also we call it sigma. And by having this number, yeah, let's calculate it. So 10 minus 2 divided through 6, and we have 1.33 days. So what does this say now? And you see it later on. This now tells us that with a confidence of nearly 86.27%, or you say 1 sigma of the real development take place between 4.67 days plus minus 1.33 days. So you are, in the sense, confident, roughly 70%, that you will finish the test between 3.3 days and 6 days. Yeah. So this is just actually something which you really can consider. This is a more realistic number. So you just not provide one number, but you provide a range. Yeah. So if you say, okay, it takes 5 days. Yeah. How realistic is that? And if you ask somebody, think of that. If somebody says, okay, you have to do this and that, what would you say? How long does it take? Yeah, roughly 3 to 6 days or something. Isn't that more realistic if you say that? Yeah, and actually it is, of course, more realistic if you say that. Yeah, so this is kind of a technique where you can provide a better number with a range, yeah, of when will you probably finish your project. Yeah, and you see later what can you do actually with this. Or if I will go back to the slide then again. So, and what can you do with this right now? You say a confidence of roughly 70%. You say this is 1 sigma. Yeah, and 1 sigma says in our case, if we work with 1 sigma confidence number, so to say, then you can say, okay, roughly 4.67 plus minus 1.3 days. But we can also consider to provide an even more precise estimation, so to say. You can say, okay, you take 2 sigma, and with 2 sigma, there's the confidence of roughly 95%. And 2 sigma simply means 2 times the sigma value, so 2.66 days. And now, yes, the range gets broader. This is pretty logic. So if you think of the distribution curve, yeah, the mathematical distribution curve, so it gets broader, but we get more confident, of course. Yeah, and this is actually the trade-off we have to take. So if you want to be more precise in your estimations you provide, the range gets broader. Yeah? But here you are pretty sure. Actually, if you could say, okay, if I ran this task, if I do this task 100 times, I can say that between roughly 3 days and 6 days with 1 sigma, roughly 70 times, if I run it 100 times, I will really do it in this range. Yeah, and by having 2 sigma, I can say 4.67 days plus minus 2.6 days. I'm nearly 95% confident, and by doing this 100 times, I'm nearly 95 times, I will really match that. This is what it actually tells us. Yeah, you can do it even more with 3 sigma, 4 sigma, 5 sigma, and you see then it gets into the million or billion, but also the range gets broader. Okay. Let's have a look quickly at the distribution curve, so that maybe gives you an idea of how it looks like. Yeah. This is the distribution curve, and you see the range of 1 minus plus 1 sigma of the distribution curve, And this is actually how confident then you are with your estimations, so to say. Yeah. Of course, you don't do super complex calculations in your projects, but which takes super long time. But you can easily improve your estimations by using these 3-point estimates with standard deviation, for example, by using an Excel file, and just provide 3 numbers instead of 1, and the rest is doing your Excel file for you or something. Yeah, I had this also in this provided sheets for estimations in a bigger company I worked for. The standard sheets you have to fill in actually for the initial project estimation. This was also with 3-point estimation and was calculating this automatically, but it was actually your choice, but it was already built in there. So if you go into a company, maybe they provide you already with some assets that you can use with some Excel sheets, and then it's already built in there. Okay. This was just about estimation. So the idea here right now is that we not going to do a complete PERT analysis, that take with you to think about how to estimate. You practice a lot with agile estimation in agile teams with relative estimations on, let's say, your user stories. But you can be sure that later in some projects or in bigger projects, you have also to do some project management. For example, if you are in the position or if you are a technical team leader or something, and you have to provide some estimations, and you cannot simply say, okay, I throw story points at the management, for example. So then you really need to provide dates and estimations in a sense of Gantt charts or what else, or milestone planning. You can be very sure if you're on the position. Yeah. And then it is good to have some practice, some ideas about how can my estimations be a bit better. And this is one example how you could probably do that. Yeah. I want to show you something else. Let me go back to the slide where we have the critical path analysis. To just give you an idea of what you do with PERT estimation. So think about what you want to find out generally in PERT estimation is provide a realistic end date of your project. Yeah, this is actually one of the goals. And if you calculate with 3-point estimate every single activity, every task, yeah, by having these 3 values, you can then provide the calculated average value, so to say, for having a kind of a bit better estimation for all your tasks, and provide one most probably end date by looking at all these dates. But you can also play around and see, okay, where can we come out in our project end if everything goes well, so to say. In our case here, what we see here, let's assume this is the most optimistic. These are all the optimistic values we have here right now in our tasks. And then the earliest end date is kind of 1st of February, for example. And then you can analyze it even further. What happens if I just take more pessimistic values, for example? Yeah. What is then happening? And then you get a better idea what would happen with your critical path and what is the consequence on your project end date. Okay. And this is generally, roughly said, the idea of why you do these PERT estimations. So get better project end estimations, more realistic project end estimations. But for us here, it's important to play around a bit with some estimation technique, so to say. Yeah. One other thing I would like to show you. So, for example, how easily, this is what I created in a few minutes. Just also for explanation, you see here some activities, some tasks, and I just took some use cases. So making a use case diagram, making a use case description, making an activity diagram or something, and you provide even these three values. Yeah, so you provide an optimistic, a most likely, and a pessimistic value. And then you get in the end a calculation. Yeah. Automatically, it calculates an example for 1 sigma. So you are nearly 70% confident that your estimation, so that you finish your task between 2.3 days and 4.6 days. Yeah? This is what is written over here. Yeah. So plus sigma and minus sigma. Yeah. So you can also go even further and say, okay, you see, but I can even be 95% sure that I finished this task in 1.1 days or 5.8 days. Yeah. So like providing a more realistic range, so to say. In the end, you have to calculate with a specific confidence for all the tasks to come out with a really realistic end date of your project, for example. But if you do it like this, it kind of improves a bit your estimations. And you can use it either for just getting to a bit more realistic values with this 3-point estimation, yeah, but weighting 4 times the most likely value. Or you can even consider also taking the confidence of the sigma into account, the standard deviation, and then you play around with these ranges if you want to. Yeah, or if there is some kind of uncertainty in your project. Yeah, and this is a nice thing because you can now play nicely around with these values and see what is happening over there. And you see, usually I would have said 7. Yeah? If everything went well, I say, okay, 3. So this use case, make it 3, or let's say these are hours. And here we have 20 hours of work, and let's take 8.5 as value, for example. Yeah. And if I want to know when will my project end, I can have a look at taking sigma into account if I would like to. Or if somebody would like to ask you when are you finished with that, you can say, for example, yeah, I'm roughly 2/3 sure, 70% sure that we will finish between 5.5 and 11 days or something. Yeah, so a bit more professional estimation. Okay, good. This was it for today.